How do kernel and user mode drivers interact in Windows? Imagine your computer as a busy city with different zones. Some parts are high-security areas, and others are open to the public. This setup keeps everything running smoothly and safely. In Windows, this is similar to how drivers operate into main modes, user mode and kernel mode. These modes work together to make sure your hardware and software communicate properly without causing crashes or security issues. User mode drivers are like the city's visitors. They have limited access and can only do certain tasks. Each user process has its own private space, so if something goes wrong, it doesn't affect the whole city. These drivers handle things like user interface tasks or simple device interactions. They rely on the operating system to request more complex or hardware-related work. Kernel mode drivers are like the city's security team. They have full access to everything. They can directly control hardware and manage core system functions. Because of their power, they need to be carefully written to avoid causing system crashes or corrupting data. These drivers handle critical tasks like managing disk drives, network cards, or graphics hardware. Interaction between these two types of drivers happens through specific channels. When a user mode driver or application needs to access hardware, it sends a request called an I/O control code or IOCTL. This request is passed to the kernel mode driver via system calls. Think of it like sending a message through a secure courier. The kernel driver then processes the request, interacts with the hardware, and sends back the results. This process can be synchronous, meaning it waits for the response before moving on, or asynchronous, where it continues with other tasks and gets the response later. For example, a user mode driver might handle the user interface, but when it needs to read data from a hard drive, it sends a request to the kernel driver. The kernel driver then communicates directly with the hardware, retrieves the data, and sends it back to the user mode driver. Kernel mode drivers also use a system called I/O request packets, or IRPs. These packets help manage tasks like reading, writing, or controlling devices. They allow the system to handle multiple requests efficiently and keep everything organized. This layered approach in Windows helps balance speed, security, and stability. Kernel drivers do the heavy lifting with hardware, while user drivers and applications stay in a safer, restricted environment. This design reduces the risk of system crashes and keeps your computer running smoothly. So, in simple terms, user mode drivers ask for help from kernel mode drivers through well-defined messages. The kernel drivers then do the hard work and send the results back. This interaction keeps your system stable and secure while still allowing flexible device management.